Hello and welcome to another episode of the Fully Charged podcast, coming to you from the fantastic, wonderful country of Australia. Now, this is probably the last one that we record here. I'm heading back to the UK quite soon. I'll be very sad because it is an extraordinary place and there's so much going on here, and I haven't even scratched the surface. Like all I ever do every day is learn about some other amazing project that's going on in Australia that I haven't been to visit or heard about or seen. But hopefully we're going to be able to resolve that with our wonderful Australian presenters. And one of them is going to join me today on the podcast. Rosie Barnes is an engineer. She runs an incredibly fascinating YouTube series called Engineering with Rosie. And she as she will explain, has worked in the wind industry a great deal, both in Australia and in Europe, in Denmark, where she lived for many years. So she really knows a thing or two about how wind turbines actually work, what they're made of, and what they're capable of producing. So it's a kind of, this is definitely a wind-focused episode. I won't say any more about Rosie because she's amazing and you will be impressed. I'm very confident of that. And her first episode is on the Fully Charged show. It actually came out today, but by the time you hear this, it'll be in the past. That's the way time goes. It kind of moves in one direction. Enough of that. I don't want to tell you anything about anything else we're doing, except we've got some amazing shows lined up that are coming on the Fully Charged show and on the Everything Electric show, our sister channel, which is growing very rapidly. It's amazing. All I would love you to do is tell your friends about the Fully Charged plethora of products and about the live shows we're doing. And I'm not going to talk about them now because I don't want to be just always go on. I'm always going on about the live shows, but they are incredible. I'm about to go to Sydney to go to the Fully Charged Live, the first one we've done here. And it's very exciting what's going on and how much interest there is in what we're doing, which is really just fantastic, very reassuring in what can often be quite a negative environment in terms of the information that's spewed out about renewables and clean technology and the electrification of ground transport, all critically important things for the entire human race. We're not saving the planet. The planet doesn't care. The planet's quite happy as it is, whether we're here or not. There's no anxiety as regards the planet. It's the human beings I think we should be anxious about. But that's enough of my waffle. Please do subscribe to this podcast and to the live shows. I won't say that at the end. I'll just say goodbye. But before I do that, please welcome to the Fully Charged podcast, Rosie Barnes.
Yeah, well, so I started out shortly after finishing my engineering degree. I wanted to work in renewables, and so I was working for a solar research company, designing equipment for them, research and manufacturing equipment for them. But it was quite experimental. I ended up leaving there and worked on some other projects for startups for renewable energy. And it was always the same. It's like, yes, technically I work for renewable energy, but I couldn't say there's like a single electron that's been generated from renewable energy instead of fossil fuels based on the work I did.
Right.
And at the time, so it was, like around 2010 in Australia, the politics here were just like absolutely toxic. I was totally despondent. I'm a real pessimist by nature, which I think is quite common for engineers because, your job is to look for problems. So
Yes.
That works well. And I was just thinking, how is it possible that we know, climate change is a thing and that we need to change things, and no one seems prepared to, suffer even the tiniest little bit to solve climate change. And at the time, wind energy and solar, both of them weren't at grid parity yet. They were both still more expensive than fossil fuels, but you could see based on the trajectory that it was coming. And I thought, I want to have some impact. I want to work on something that's going to, make some green electrons. And I wanted to get out of Australia because I was just so sick of the toxic politics.
Right.
So I I knew I wouldn't probably get a job in at a big manufacturer like I wanted to. So I went back to university and did a PhD, and I chose a wind turbine project so that would make my CV very appealing to
Right.
to a big wind energy company. That was my plan. And yeah, I chose wind energy because my technical love is composite materials, and then my values say renewable energy, and wind energy is just this big big generating behemoth. At the time, it was way closer than solar was to having a real impact. So when I finished that, I think I handed in my thesis one day, and on the very next day, I was on a plane to Denmark to meet the team of a company I had a job offer for. Um, and then I took that job. So I lived in Denmark for 5 years working
Wow.
at LM Wind Power, and they're the biggest wind turbine blade manufacturer in the world. One out of
Right.
5 turbines in the world have blades made by them. So it's the biggest renewable company you never probably heard of. And they got bought out by GE Renewables while I was there. So I was eventually
Right.
an employee of GE. Yeah. And then the pandemic happened. It became very hard to live on the other side of the world from where my family was. My partner, his job was still in Australia, so he couldn't be stuck in in Europe.
Right.
And so, yeah, came back, started the YouTube channel while I was out of work and with no prospect of finding more while the pandemic was raging. And I just enjoyed it. And I just surprised myself that people actually wanted to listen to
Yeah.
videos about engineering, really getting into the engineering. Not just renewables, yay, but I'm always talking about the problems and how they're going to be solved. And
Yeah.
that's my story.
That's good. No, well, what an amazing story. I mean, it's brilliant. And I mean, are you now working for? Are you doing any engineering work now? Have you got a job? I suppose is the basic question.
Yeah, I have a couple. I have one. So mostly what I do, I try and spend as little time on the YouTube as possible. So every time I make some money from the channel, I spend it on hiring staff to do the parts that I am less good at and less
All right.
interested in. So right now I'm working on hiring a writer because I've noticed I've started procrastinating terribly on the writing, and
All
I'm
right.
not enjoying it that much. So yeah, hoping that will go well. And then the rest of my time, I have a consulting company, and I consult about clean energy technology development. So yeah, all of the work that I've done has been on physical products,
Right.
developing them. Basically, once you've got 20 years of engineering experience, you've seen a lot of things break, and so
Yeah.
I can look at technology and say, this is how it's going to break, and then basically try and break it as quickly as possible. So you would rather break something in 6 months than in 6 years. It's a lot cheaper
Right.
that way, and then you can make your product better.
Yeah.
Yep. So I do that. Also doing a bit of due diligence, like engineering due diligence for companies that want to invest in renewable energy technologies or acquire a company. That's something that I wish more companies would do, because you see so many just
Yeah.
shocking decisions made, even by like government investors that invest in technologies that break the laws of thermodynamics. And
Right.
if you just given me a couple of hours, I could have saved you $100 million.
Millions.
But
Yes. Oh
anyway,
God.
yeah,
Wow. But then,
yeah,
because I mean,
yeah.
what
So I
I
do a
don't
bit of
know
that.
much, what I don't know much about is the extent of well, let's stick with wind at the moment, because I'm kind of very aware of the amount of rooftop solar in Australia. That is very noticeable. You don't have to be an engineer to notice that. You just have to kind of look at roofs. But wind turbines, I remember seeing a huge cluster of them on a hill, I think in southern New South Wales, when I was driving down the coast. So it's not like there are none,
Mm.
but there seems to be. I don't know how many there are, and is Australia developing offshore wind as well as onshore? Because I don't know what your coast, that, as you know from being in Denmark, there's this incredible opportunity there because of a very low sea, very shallow seas around Denmark and in the UK, in the North Sea, which is why we've got so many
Yeah.
wind turbines there. Is there similar areas here in Australia?
It's not as good in terms of shallow waters, but I think the real thing stopping Australia from having a lot of offshore wind already. I mean, we have none now, and we've just recently had our first offshore wind farm. It's not been given the green light, but it's been given major project status, I think. So that means that they're kind of like expecting it to happen and trying to speed its rollout. But the reason why we don't have more, I would say, is because we have it too good in terms of onshore wind.
Right.
So. Yeah, we've still got plenty of space left, and including some really, really good sites. I was talking to someone from one of the developers recently, and they've got a wind farm planned, a really big one in South Australia, and the capacity factor that they're expecting for that is it's at least in the 40s, and maybe pushing up to 50%. I can't remember the exact number, but that's so capacity factor is how much energy it's producing compared to the rating. So if you've got a 1 megawatt wind turbine and its capacity factor is 50%, then on average it's making half a megawatt. And so there's these onshore resources left that are as good as offshore in many cases, and offshore wind is still more expensive than onshore. It's about half the price of offshore. So you need really compelling reasons to do it. And when you see a lot of offshore wind happening, it's places that, yes, where it's easy because water is shallow. But I think the more important thing is that there aren't a lot of other options. So Denmark, for example, it's a small place. It's pretty jammed full of wind farms. I was living in Jutland in a small town called Kolding, about 2 hours north of Hamburg, and there's just wind farms everywhere there. It's actually really cool because you can see it's like a little outdoor museum of wind turbines, because there's ones there from the 70s. I actually went and visited one from the 70s that's still going now.
Wow, that's amazing, isn't it? God,
yeah, and everything impressive. In between.
Yeah,
but Danes don't want more onshore wind farms. Neither do Germans, Norwegians. Like everybody is complaining about more wind farms onshore in Europe because they're so packed in. And so they don't have so much choice but to go offshore. And in Australia, we don't have that problem. We did in the early days have a lot of trouble with community acceptance, and people were worried about wind turbine syndrome and that sort of thing. I don't hear about that anymore because the developers have gotten much better at realizing that it actually matters what communities have to say. It's not enough to say as an engineer, wind turbine syndrome doesn't exist, therefore I'm going to ignore it as a problem, because it becomes a problem too when people believe it and are seriously affected by that belief and don't want a wind farm anywhere near them. So that's my thoughts on offshore. But there's a lot of benefits as well. Like the project that is going to go ahead in Australia is a Star of the South project in Victoria, and one of the benefits that they're saying is not just that it's got high wind speeds and it's windy a lot of the time, but also that the time when there's the best wind resource is in the late afternoon usually, which matches really well with when there's peak usage. And that's something that solar can't really help with, because, by the time it's late afternoon, there's very minimal solar power, and, a little bit later, none. So they're expecting to be getting way higher prices for the electricity that they generate, and that will compensate for the fact that their wind farm is going to be a lot more expensive to install and maintain.
But then the other aspect of it is that, you've got plenty of room for it. I mean, I think that's the case in the UK as well, the case I know. I mean, we do have wind farms. Scotland in particular has an enormous amount. I mean, a lot of people in the south of our island, in England, who go, renewable energy just doesn't work, are actually able to say that because their lights are on, because there's so much wind energy in Scotland. We're producing such high amounts of electricity. But that's a whole other discussion. But the scale of the size, because that's what I'm fascinated by. I've only had very minimal, but I've had some experience of the red centre. And the scale of this country is so mind-bogglingly enormous that it is very hard to take it in. I think even for Australians to actually really understand how big it is. But I mean, is there the potential for wind, particularly wind, because that's very obviously there's potential for solar, but I don't know if there's potential for wind sort of further inland. I mean, is there a point where it just isn't that windy in the middle of the country, or is it windy everywhere?
I think it's more about the transmission than anything else because,
Yeah,
yeah, it's so big. But if no one lives there, then then you don't have transmission there. So if you have to build a whole transmission line for your wind farm, then very quickly the economics evaporate. So
yeah,
where you do see people trying to take advantage of wind resources in the desert, there's a lot of the giga projects. I've heard them called. Like multiple gigawatts of wind and solar power together, co-located in areas, like in the desert, all across Western Australia, some in South Australia as well. But they're not close enough to any population that you would consider actually using the electricity there in like here in Australia in
yeah.
general. They're all got to think of other ways that they can export that wind and
Right.
solar power. So one of them, Sun Cable, is planning high voltage DC transmission that will partly supply Darwin in the Northern Territory, but mostly it's supposed to supply Singapore,
Oh,
maybe
that's
India
right.
along the
Yes.
way.
Yeah.
Yeah,
Yeah.
that project's having some trouble at the moment. It's got our two like climate change billionaires.
Yes.
Neither of them are rich from climate change activities, but
Yeah.
they're both billionaires from something else and spend their money on on climate change related businesses. So that's Andrew Forrest and Mike Cannon-Brookes. They had teamed up along with some other investors on this project, and now they're having a bit of a spat about
Yes.
how it should play out. So
Yeah.
I hope that project continues because it's exciting. But all the other projects like that, they're planning either hydrogen or some derivative of hydrogen as a way to transport
Right.
that energy offshore.
Yeah.
It's tricky.
Yes. Yeah. No, it is. But I mean, that's because the other aspect that I'm staggered by, having been up close to a couple of very big wind turbine blades. Well, that's obviously I mean, I'm fascinated by the physics, the materials, how on earth you can make something that is basically an enormous lever that's only joined on at one point that is over 100 meters long. It just makes, it makes no sense to my very crude grasp of physics. That should just fall off. It just shouldn't be able to stay there. How on earth does that work? The strength involved is staggering. And I mean, and because they're not, I sort of think, oh, they must be very light because they're made like airplane wings. They're not that light. They weigh tons, don't they? I mean, they're huge things.
Oh yeah, many tons by the lengths that we're up to now. Yeah, I mean it's the magic of composite materials, I guess. That was composite materials was actually probably my first engineering love, and the reason why I ended up in
Right,
engineering. I used to race bikes competitively, and all the best bikes are carbon fiber, and I don't
right,
know. It's just it is like a magic material because it's not like most materials that you work with. Like a metal has the same properties in all directions. It doesn't matter which way you bend it; it's going to be as strong and as stiff in every direction. But composite materials with fibers in them, you line them up in the direction that you need to be stiff or strong, and it's very stiff and strong in that direction, but not in the other directions. And so
right,
you can be really targeted, and that's how you're able to save so much mass.
right.
Yeah.
Wow. And because do you think there is a limit? Because I can remember someone I spoke to like 10 years ago said we're sort of at the limit,
Yeah.
who was involved in, I think it was someone at General Electric actually, said we're sort of kind of approaching the limit of size. I mean, and now looking back at what they were making then, those are tiny. Those are pathetic little
Yeah.
things like 55-meter blades, without left that long behind. I mean, but I'm assuming there's got to be a physical limit,
Yeah, it's funny. This is a question I get asked a lot, and I
I'm
made a
sure,
video on it recently. So viewers should check that one out. I think I called it "How Big Can Wind Turbines Get?" or
That's right.
something like
Yes.
that.
Okay. Yeah.
But I started off in that video, I started off with a story because when I was working in Denmark, you celebrate employees' anniversaries, right? And in Denmark, people are quite loyal to their employers. So there were a lot of 10 years and 25-year anniversaries.
Wow.
25-year ones were the best. But what happens is everyone gets in the canteen and the company buys cake, and then the employer who's been celebrated, they give a little speech, and they all follow the same pattern. They all start off with, when I started in
Yeah.
1990, wind turbine blades were 12 meters long, say, and we all thought, we all wondered how long can they get, and we thought 20 meters. They definitely can't go past 20 meters, and now wind turbines are 100 meters long, or 140 in the longest case. So people have been having this conversation, exact
For a long
conversation
time.
for decades. Yeah. They've got to be close now, right? And yeah, so because my background is with structural design of wind turbine blades. So I made this video on the scaling laws about how you would actually, what happens as you increase the length of the blade, then what has to happen to the structure. And the interesting thing is that a lot of people think, economies of scale, it's just bigger is better in all cases. But in terms of wind turbine blades, there's some things that favor bigger blades, and that's things like connection to the grid, and what else? Yeah, just having a smaller number of things, of towers and that sort of thing. But then there's plenty of factors that are actually wanting wind turbines to be small. So in terms of actually blade mass, you would get much less blade mass if you had 10 1 megawatt turbines than 10 megawatt turbines.
Oh, right. Okay.
It's because the power that a wind turbine captures is proportional to the square of the blade length. It sweeps out a circle. So that's, pi r squared. But then as you increase a blade, if you double the blade length, the volume doesn't increase with the square, the volume increases with the cube. So you've got a square increase of the power, but a cube increase with the volume and the mass of the materials.
Right.
So you can do a bit better than that if you start, getting better design methods and adding carbon fiber instead of fiberglass and that sort of thing. But in general, smaller is cheaper for blade materials. And so when people say what's the optimal size for wind turbines, the answer is always the optimal is right now is what they're selling right now. And then when things change, they'll change the size of the turbine, because the wind turbine companies are really, really strongly incentivized to make the turbine that overall gives the cheapest cost of energy, or is the most appealing to their customers. So that's what they're doing. There's nothing stopping us from making a 200 meter long blade now. It would just produce electricity that was more expensive than the blades we make now. And it's also a reason why you see offshore wind turbines are so much bigger than onshore ones, because they've got different design constraints. Onshore transport is a big problem, keeps things small. Offshore, it's not a problem, so they've got more freedom to grow.
Yeah. But I mean, that feels sort of counterintuitive, what you said, because I do remember there was a story I think I covered on the show a few years ago of some very early offshore turbines off the coast of Denmark that had reached the end of life. I think there was 12 of them, and they took them down and replaced them with one which produced more electricity than the 12 original ones. But that's also, I guess, down to the technology that was available whenever they were put up. 12. I think it was like they were like 25 years old. They were old, by wind turbine standards.
Yeah, the first offshore wind in Denmark was early 90s, I'm pretty sure.
Right. Oh, so a long time ago. Yeah. But then, but what you're saying is that isn't necessarily the case. We could have, because I thought, the tower, the actual generator, the connection, all that stuff. If you only have one big one, that I sort of feel that's less. This is my crude analysis. Please forgive me. It's not very scientifically based. But if you have one big thing rather than 22 small things, there's sort of less stuff involved in producing that, I'm guessing.
Well, I mean, the installation of it and the maintenance of it will all be easier. But in terms of actual materials in the tower and the blades specifically, then it's the opposite. You'd have less if you had more smaller ones. Yeah.
Right.
So it's just the constraints are different to what people think, and they're moving all the time because, like for onshore wind, one of the big constraints that's stopping them getting bigger is that tower diameters. If you make them in one piece, in sections, but the whole cross section is all in one piece, a tube
Yeah.
basically. Um, they transport them on the road, and so the diameter can't be bigger than what you can
Right.
transport on the road.
Yeah.
But now you see people are trying to make like spiral welded towers.
Yeah.
People are making towers out of other materials. Yeah, and then another constraint is cranes. Getting a crane big enough that can actually, install a wind turbine, higher and
That
higher.
high. Yeah.
That's
Yeah.
becoming a constraint, and so you see technologies emerging that can like climb up. They install themselves, kind of. It's
Oh, wow.
like a crane that clings onto the tower it's made so far, like a koala, and then it installs the next bit and then climbs onto it and installs the next bit and climbs onto it,
Wow.
and so you don't need a big crane. So as the technology, as is one constraint, there's an incentive for someone to come in and with a new technology that removes that constraint, and then
Yeah.
things keep on going again. So I think that's why it's really hard to say what's the limit to how big they'll get,
Yeah.
because you can't possibly imagine what the crazy technologies are going to be in the future that remove that constraint.
Yeah. And I mean, I'm guessing that it must be an incredibly exciting field to work in, because of the developments that are happening and the speed of those developments. I mean, you could work in, I don't know, I'm just trying to think of a more dull aspect of engineering. I mean, even bridge building, the kind of basic concepts of a bridge. We've kind of worked that out. This is how you make a bridge, and there may be slight changes. But wind turbines, it just feels like the whole industry that's developing around it and the technology that's developing around it is on such a steep
Yeah.
growth curve. It must be a very exciting area. I just
Yeah,
very quickly, I mean, related to that, it's the number. I've just read another thing about it. The number of people who used to work in offshore oil and gas who are transferring into offshore wind is very noticeable, very clear connection in skills.
yes, yes, I love that. That's one of my
Yeah,
favorite things of offshore wind.
right. I mean, that is something that you've experienced. I mean, it is a well-known phenomena.
Yeah, yeah, I do. I have a podcast myself. I co-host on wind energy stuff called the Uptime Wind Energy Podcast, and one of my
Right,
co-hosts actually, he used to work in oil and gas, and
right,
now he's in wind energy, and yeah, I know heaps and heaps of people. But it's
right,
true across all kinds of renewables. It's one of my favorite topics to talk about is how
right.
politicians in Australia at least always seem to think that it's like this choice between renewable energy or jobs. But
Yeah,
obviously that there are a lot of jobs needed in renewables, and it's funny as an engineer because you try and design something that doesn't need a lot of maintenance, but wind turbines do need a lot of maintenance compared to solar power. Not as many compared to a lot of other forms of like fossil fuel generation. But maintenance, a lot of maintenance means a lot of jobs. And in the case of wind farms, it's really similar kinds of jobs to what have been needed in fossil fuel industries. So, like I was climbing a wind turbine in Canada one time, and one of the technicians I was climbing with said, I used to be a coal miner. My dad was a coal miner. My granddad was a coal miner.
wow.
Probably his great granddad too. And he said, you know what? It is so much nicer being 100 meters above the ground than below it. That's for sure. So he transferred right over.
Yeah,
It's not like some kind of magical skills. It's normal mechanical, normal electrical stuff,
yeah.
and then you train for the industry specific stuff that you need and carry on. I don't know. Are you going down to Newcastle at all on your trip
Yeah, I have.
over
Well, yes, I have. Yes, I went through Newcastle. Yeah, so I don't know
Yeah,
it
because
at all.
that's
Well,
one
I
of
spent one
my
night there.
yeah, well, it's like traditional coal country in
Yeah,
Australia, the Hunter Valley. It's full of coal mines and heaps and heaps of coal mining jobs. And I've spent a bit of time there because it's also a whole lot of companies that are emerging to with clean energy technologies, and all of them are after they're hiring. They're all growing fast. They're hiring people that have mining backgrounds, because
Right.
the processing equipment is the same as what you need for a lot of similar clean energy technologies.
Yeah.
Yeah, and there's just so many innovative companies springing up there. A lot of people who have ideas for what you can do with a coal power plant once you're not using it to burn coal anymore. Yeah, I think people really underestimate how, I don't know, how flexible people are.
Yeah, yeah, I think so. Absolutely. No, I agree with you. And I mean, that's what's some of the exciting technologies that I get excited about. Then I think there's a pattern has emerged in my head anyway, that you will hear some really weird, outlandish technology being proposed, and then it goes completely quiet for years, because if you don't know the people actually working on it, and then it comes back. And there's been quite a few things. There's a company in the States called Quaise Energy. Have you heard of them? Who are doing deep
Oh, so that's
geothermal.
geothermal.
Yeah, and I mean, I heard about them a long time ago, and then nothing happened, and they're now doing their first test drilling. What reminded me of it is it's at an existing gas turbine plant, so they're replacing the gas with geothermal. But the plant already
Yeah.
exists. It's already got a grid connection. It's already there. They don't have to build a new one. It's that if it works,
Yeah.
it's one of those. If it works, it would be extraordinary. But that's yeah. I mean, it's slightly different technology to wind. But I mean,
Yeah.
because I mean, I just wanted to go through that. What you did in the episode for us about the possibility then of how you counter the at the moment I feel torrent of information that's coming out of the fossil fuel industry lobbying groups. They've got a lot of money behind them, to say there's no way we can be 100% renewable, and it's they're doing all this stuff. It's a cruel myth that middle class elitists, and in one occasion on one article in the UK they referred to me, are forcing this on hard-working families who are struggling to pay their gas bills. And you can't. And I'm chewing my fist to go, what if they didn't have gas bills? What if they didn't
Yeah.
burn gas? There's that. Anyway, but I mean, you seem groundedly optimistic that it's possible to. Let's stick with Australia to make Australia 100% renewably powered.
Yeah, I don't just think it's possible. I think it's inevitable, because
Right.
it's cheaper. The economics are there. So I said, that one of the things that caused me to go to get this job in the wind industry back in, I think, 2016, I started that, was because wind power was close to grid parity at that time. It was
Yeah.
nearly as cheap as coal or gas, and now it's much cheaper. Yeah, if you look at just a kilowatt, and you don't care when or where it's generated. So the next thing is making sure that you can get the storage and transmission and everything, so you can
Yeah.
get the whole system working. But yeah, I was so frustrated by the politics, and I was frustrated in people, because like, why wouldn't you pay a bit extra to save the planet?
Yeah.
It's still really upsetting to me that we kind of lost that. I have come to accept that people won't, or not enough people will, that it would make a difference. If you relied on everybody not flying anywhere for a holiday because they felt bad about the environment, felt bad about everyone giving up meat even though they like it, just for the environment. Like, what are you going to get? Like 5, 10, 20% of the population that might be on board?
Yeah.
It's not enough, right? I
Yeah.
just became convinced that the only real solution is that the vast majority of these greener technologies become cheaper and better than
Yeah.
the fossil fuel alternatives, and in the bulk of cases that's true. So yeah, wind and solar are just so much cheaper that you've got money left over to spend on storage and things like that to
Yeah.
get the whole grid working. And in Australia, we see coal plants announcing their closures constantly. Every few
Yeah.
months there's another one bringing forward a closure, and it's definitely not because the government's told them to. And until recently the government would have been prodding them, no, you can't
Yeah.
close. You're not allowed. We're going to try and force you in our our free market. We're going to force
Yeah.
you to stay open, operating at a loss. but yeah, the fact is that it's just not worth it for them to keep going anymore. And so that's, that's a durable solution, that it doesn't matter if the government gets thrown out, or I don't know, people change their minds, or there's a cold summer one year, or all that stuff doesn't matter because the economics is there. And I think electric vehicles isn't so far behind now. I mean, we're
Yeah.
already at the point wherein, if you look at a lot of people say that the total cost of ownership is cheaper for
Oh,
electric
it's
vehicles
way cheaper.
already.
Yeah.
So soon the purchase price will be cheaper. And at that point, I just think, there's just no going back. It'll, be very, very sudden then. And I wouldn't say that every single source of emissions has a clean technology that's waiting to
Yeah.
become cheaper and better, but the bulk of them do. And I just see so much momentum now. And so I don't get frustrated by the politics anymore, even before excuse me, even before our government changed. Um, it's irrelevant. They've made
Yeah.
themselves irrelevant by not doing anything. I don't care what they I don't care what they say. I would much rather that they were helping, but they can't stop it. They just
Yeah.
can't. And so that's why I prefer being an engineer to being a politician or an
Oh,
activist
gotcha.
or anything
Yeah.
like that. Yeah, that's why I'm able to
Yeah.
have the sense of optimism.
The other one thing that I'm intrigued with, which I think will happen, and it's a really simple technological shift, is the constant struggle to balance supply and demand, and that the grid is built to do. That, but the what's recently happened in the UK, and I've been doing it remotely, is you reduce your energy supplier asks you to reduce your demand between a specific. It's usually 1 hour or 1.5 hours. You don't have to sit in the dark and the cold, but you reduce. You don't put on your washing machine, your cooker, your top, for that period, and that has made mind-boggling impact. Much more than I ever expected. It's about 450,000 people just turned everything down a bit for that time, and it resulted in like gigawatts of reduction in demand, and therefore cost, and therefore the benefits. And it's just that it's the same frustration. If 4.5 million people did that, it's
Yeah.
all that gas peaker plants, it's all the coal plants that have to be fired up to cover that gap. You just
Yeah,
It's not that hard
it's
to do.
crazy how little people think or talk about this, or how little a difference they think it's going to make. But I'm convinced. I actually just made a bet with someone this morning about what the solution. We were talking about Texas, and they had their Texas freeze, and
Yeah,
now they're changing the laws so that everything has to winterize to be able to ride through something similar in the future.
yeah,
And I was saying how it's crazy that people can still be running their outdoor jacuzzi at the same time
yeah,
that someone in a nearby district is freezing to death, like literally
yeah.
freezing to death in that case. And that I think that that's going to be the big story of the next few years, like 2 or 3
Right.
years, is going to be all of that demand reduction stuff finally working. Because I can see some companies now have finally figured out the way to make it work. Because, when you talk about it, it sounds so complicated. It sounds, like, oh, are you really going to call up, like 1 million people and ask them to turn down their thermostat, or,
Yeah.
stuff like that? Or I don't trust the government to turn off my air conditioner on a hot day, things like that. But it's not how it's going to work. It's going to be, in my opinion, it's going to be companies that find a way to give the value to the consumers, because it's
Yeah.
immensely valuable to reduce load by a
Yeah.
meaningful amount if there's going to be a shortfall, to avoid a blackout. In the Australian electricity market, at least, the cost of electricity varies between like negative $1,000 and up to plus $15,000 a megawatt hour.
Wow. Wow.
And so,
Amazing.
I mean, it's it's hugely valuable, but we don't see anybody but the very, like aluminium smelters are allowed to play that game, but
Yeah.
not not you with your solar panels and your car plugged in and household
Yeah.
battery and all that. You're not allowed in at the moment. But I do see companies that are starting to find a way to get households to financially benefit from helping the grid out. There's one Australian company actually called Red Earth who they're in Brisbane. Actually, you should go visit
All
them.
right.
They've got this cool app, and it just has like a big dollars number on it about how much you can make if if you reduce your load by a certain amount at this time. And in Australia, it's all quite real time. I think the UK market might be a little bit different because you've got to predict the day ahead and stuff like
Yes.
that. But
Yeah.
in Australia, it's much more like responding every 5 minutes. Prices are changing, and so you just got an alert. Oh, hey, the electricity is negative. If you charge your batteries now, and you'll make money. And you set it up obviously so you don't even have to get the alert and change it. It just happens. And I think that those kinds of systems are about to take off and are going to massively reduce the amount of storage that we need in a 100% renewables system, massively reduce the amount of extra transmission and distribution that we need. I think there's so much to be gained. And, I think people are still thinking about our electricity market like trying to make it look like a fossil fuel system.
Yes.
And without realizing that in itself was really complicated. It's not like electricity demand is constant, electricity generation is constant, and they're just the same and everything is good. Demand is constantly going up and down very fast. Coal power plants shut down, in a matter of minutes sometimes, and it's a gigawatt or two coming offline at once, not like a 2 gigawatt wind turbine or something coming off. So I think, people don't realize how complicated the old system was, and that there is no need at all to replicate that with the new one. I think we're starting to get close to the point where we won't keep trying to do that.
Yeah, I mean that's really, I think, a critically important point, because that in a sense relates to electric vehicles as well. Is the hours I've spent trying to explain to people, an electric car is not like a petrol car, because you don't have to stop or change your journey to go and charge it. For 90% of the time you're using it, you charge it when you're not using it. I try and kind of come up with silly analogies, like imagine you parked your petrol car on the side of the road and there's some machine that is dripping petrol into your tank very slowly all night while you're asleep, and you wake up and your tank's full. That's how to think of it. There's constant, but then you think, I really don't want to live in a world where there's petrol dripping anywhere. But, I think the other one is that I was sort of aware of, having made a TV show about a big coal burning power plant, is that the general public will hear, wind turbines, unreliable. What happens when it's not windy? Solar panels, unreliable. What happens when it's nighttime? Coal burning power plants, gas power plants, unreliable, because they break and they have to be shut down sometimes for months. Nuclear power stations will be shut down for years. We don't know that because the whole grid has been built to deal with that, because that's just how those things work. But I think the general public have no idea that that's the case.
No, and it's a definite truism that no matter what the energy crisis, renewables will be blamed for it.
Yes.
We had one recently in Australia. Prices, shot up, and there were a few causes. One of the problems was that there was some coal power plant that had unscheduled maintenance, and it was taking a long time to repair it. Another problem was there was a lot of flooding, and some of the coal power plants, their coal mines were underwater, and they couldn't get fuel for their coal power plants. And prices went very high. The other issue was the international, high gas prices. And Australia has heaps and heaps and heaps of gas, but we export nearly all of it. And the amount that we use domestically, actually, the biggest domestic user of gas is gas export industry. They're using it for their own processing.
Wow.
Yeah.
Wow.
And
God.
So when our local price, even though we've got so much more gas than we need, our local price is really tied to the international price, and that's been high for reasons that everyone is well aware of. But that doesn't stop right-wing politicians blaming it on wind power or
I
solar
always
power.
blame wind power.
Yeah, it's funny because I'm in Canberra and we have 100% renewable electricity here. It's all through, power purchase agreements. There's contracts for difference.
Right.
And so when the price of electricity from our wind and solar farms that we have, an interest in, when that's higher than the market, then we pay. Then we pay the difference. But recently, it's been the opposite. The renewables have been lower because obviously their fuel price doesn't increase just because the wind doesn't get expensive just because gas is
Yes.
expensive.
Yeah.
So next year, everybody across Australia, everybody's electricity prices are going up, except for Canberra. Ours is going down. So we're
Wow.
100% renewables, and our electricity bills will be going down next year.
Going down.
Yeah.
Wow.
So
That's a
yeah.
fairly good advert for maybe changing the way you generate power. Wow. I think that's a very optimistic, or it's a mixed message, but it's mainly optimistic that it is possible for the economics, the economic benefit. I think, which is what you've been saying, the economic benefits to play through, for people to go, I don't care what makes my electricity, I just want the cheap stuff. In which case, the answer is, well, it'll be renewables, which is really, we have to sort of grip onto that through these difficult times.
Yes, definitely.
That's fine. But Rosie, I want to thank you so much for your time today. It's been really good talking to you. Well, I really hope you enjoyed that. It was fascinating talking to Rosie. I'd never met her before. We're meeting in person next week for the first time, which is very exciting, along with many other people that have appeared on the Fully Charged show, including Elliot. Elliot is coming down from Shanghai to Sydney, and we've never met. We've talked together for years now, many years. I've never actually met him, so that is going to be very exciting. That's it, though. Please do tune in for the next episode of the Fully Charged podcast coming your way very soon. But as always, if you have been, thank you for listening.